Throughout Earth's 4.5 billion year history, our planet has been through some wild swings. We had supercontinents, mass extinctions, and even asteroid wipeouts. But nothing compares to the time when the entire globe turned into a giant ice ball. For nearly 100 million years, from about 720 to 635 million years ago, Earth has locked in what's called the cryogenic period, a total deep freeze where ice sheets covered everything from the equator to the poles. These numbers are insane and hard to wrap your head around. But all you need to know is that our cozy blue world once became a snowball, with oceans frozen solid and life hanging by a thread. This means the wildest ice age you can imagine actually happened. And today, I want to break down the 5 key reasons why Earth totally froze up. So buckle up because this story is chilling, mind-bending, and perhaps a little too close to what could happen again. But most importantly, it's real. This was our planet, turned into a frozen wasteland. Let's start with the setup. The supercontinent trap. Around 750 million years ago, Earth's land masses had clumped together into a massive supercontinent called Rodinia. Huddled mostly around the equator, this was like warping the planet in a giant blanket of rock that blocked warm oceans currents from circulating heat around the globe. Imagine all the continents piled up in the tropics, creating huge, stagnant seas that couldn't mix warm water poleward. Rodinia's formation sucked up moisture from the air, leading the drier conditions and less cloud cover to the trap heat. Scientists think this continental cluster acts like a heat sink, cooling the planet by up to 10 degrees Celsius just from poor ocean circulation alone. It was the perfect storm starter if Earth were a house. Rodinia slammed the door on the thermostat. Next up, the carbon dioxide crash that sealed the deal. Back then, Earth's atmosphere had way more CO2 than today, acting like a thick greenhouse blanket keeping things toasty. But over millions of years, massive volcanic outgassing slowed down while ancient rocks weathered away, gobbling up that CO2 through chemical reactions. Picture giant mountain ranges grinding down in the rain, pulling carbon out of the air and locking it into sediments. By the time the cryogenian hit, CO2 levels had plummeted to less than a tenth of they were before, down to levels that couldn't hold on to heat anymore. This drop triggered the initial cooling, dropping global temps by another 5 to 10 degrees. Without that protective gas layer, sunlight bounced off more easily, and the planet started shivering. Sorry, prehistoric critters. No more blamey vibes. This one's so vicious, it's earned the nickname, the albedo death spiral. To the untrained eye, a little snow might seem harmless, like a light dusting on a winter morning. But once ice starts forming at the poles, it reflects sunlight back into the space instead of absorbing it. This is the albedo effect. Ice is super reflective, bouncing away up to 80% of incoming solar energy compared to the dark ocean that soak up 90%. As more ice separates equator world, it cools the planet further, creating more ice in a runaway feedback loop. We are talking glacier marching across the tropics, freezing even the steamy equator under miles thick sheet. Any early life forms thinking it was just a cold snap, badly mistaken. They would be buried under an endless whiteout, winds howled across the ice, and the whole thick locked in for 10 of millions of years. I don't know about you, but I will pass on the internal winter vacation. Up next, the volcanic shutdown that turned down the heat even more. Volcanoes are Earth's natural thermostats. They spew CO2 to warm things up over eons. But during the lead up to the big freeze, a lull in superplum activity means fewer massive eruptions to replenish greenhouse gases. Think of it as the planet's furnace running low on fuel. No big lava floods to pump out heat trapping CO2. So the air just got thinner and colder. Evidence from ancient rocks shows eruption rates dropped by half, letting the CO2 crash accelerate unchecked. This wasn't some fiery drama. It was a quick killer, starving the atmosphere of its warming lifeline. If we fast forward that to today, it make you wonder what our own volcanic hiccups would do. This trigger is looking a bit more pinpointed. Low latitude glaciation is the smoking gun that kicked off the full freeze, with boulder-strewn deposits found smack in the tropics, prove that ice reached the equator around 720 million years ago. A critical threshold was crossed. Orbital wobbles like Milankovitch crystals aligned with the CO2 drop, plugging summer sunlight to record low even at low latitudes. The planet, already cooled by Rodinia and the gas crash, couldn't rebound. Glaciers surged forward, covering 100% of the surface in under a million years. Perhaps even more exciting, this total ice over starved the ocean of oxygen at first, but it set the stage for the Cambrian explosion, later by evolving through microbes. But here's where it gets weird. Under that ice, pressure built from decaying radioactive rocks, melting the underside just enough for hidden oceans to harbor bizarre heat-loving life. Just imagine geothermal vents blubbing with alien critters, while the surface howled with blizzards. In fact, this idea was so wild that geologists now call it the Great Oxygenation Break, where the freeze forced evolution into overdrive. Not every freeze lasts forever. The breakout mystery is what finally thawed the snowball after 100 million years of lockdown. These escapes weren't part of the tidy circle. They were chaotic bursts where continents finally drifted apart, jump-starting volcanism. Rodinia began to rift, unleashing floods of lava that blitzed out CO2 like a pressure cooker exploding. We still don't fully understand the tipping point, but our best theories point to accumulated greenhouse buildup under the ice. Gases trapped until cracks formed, letting steam and CO2 vent in massive pulses. As they pierced the ice, their warming rays began to thaw the surface, eventually leaving behind weird cap carbonates, bizarre limestone layers from the sudden CO2 spike. If one such rift had failed, Earth might still be frozen today, drifting through a dark, icy void. The chances of total permanent freeze were slim, but if it had happened, I'm not sure there's much we could have done. This frozen chapter is just as real as the dinosaurs or the rise of humans, and in some cases, it paved the way for all life as we know it. I mean, we are just a fleeting blip of curious apes living on a thawed blue marble, orbiting a middling star in a vast, indifferent cosmos. For as long as we have dug into the rocks, we have puzzled over these ancient scars and dreamed about what they mean for our future. Now, I believe in climate swings, and I believe we are tinkering with forces we barely grasp. But for now, it's just us on this fragile, warming world, and maybe that's enough to make us think twice.